Hello everyone, welcome back to Science by Asha Matpal. In my previous session, I was teaching you chemical reactions and equation, which is chapter number 1 in class 10 CBSE board science textbook. It is a chemistry chapter. And I have already explained you till the topic of double displacement. Now we will be moving ahead in the chapter and I will be teaching you some more types of reactions. But before I start my session, I would like to request you all to kindly subscribe to my YouTube channel and share its link among your friends and family. And don't forget to like, share and comment. So let's begin today's session. So we were doing the types of the reaction and today we will be starting up with the precipitation reaction. Okay, so precipitation reaction, if you can recall from the double displacement, we have done one reaction which is the reaction between the barium chloride and sodium sulfate Okay, remember this kind of reaction always takes place between the aqueous state, that is when the compounds are in the aqueous state. So this is barium chloride when it reacts with sodium sulfate. Right, now we will first be writing the formula. So it will be BaCl2 plus Na2SO4. Okay, we are using valency to write the compound, so you will have to learn it. It is in the aqueous state, it is also in the aqueous state. Aqueous means what? That these compounds are mixed in water. Simultaneously you can make test tubes also. In one test tube you can take the BaCl2. Okay, in another test tube you will have to take Na2SO4. They both are white color compounds. So now what we are going to do, we will be taking one empty test tube and in this we will be adding both the compounds BaCl2 as well as Na2SO4. Now when they both are added, okay, and when you will shake the test tube, you will find that inside the test tube, in between the liquid, this is the liquid which is there, in between the liquid you will see certain particles which are hanging. These are very flaky, curdy, like a curd particle. They are hanging inside the solution and after some time they will settle at the bottom. Okay, now this solid particles which are formed, these solid particles which are formed, they are called as precipitate. In short, the precipitate is written as PPT. Now if you see this reaction which I have written here, this chemical equation, Ba is a positive ion, Cl is a negative ion, Na is a positive ion, SO4 is a negative ion. So what is a double displacement? In the double displacement reaction, we have understood that there is an exchange of ions. So now what will happen here, that this is a positive ion and in the other one this SO4 is a negative ion. Remember, opposite charges always attract. So this Ba will combine with SO4 and it will form the compound BaSO4. And this Cl will combine with Na and it will form NaCl. Right, now this NaCl is in the solution state here, or in the aqueous you can say, and this BaSO4 settles as precipitate. For the precipitate we make a downward arrow also because it settles at the base. So BaSO4 is a white color precipitate or the solid which is formed in this reaction. So a double displacement reaction is also a precipitation reaction. Remember, it is not necessary that all the double displacement can be a precipitation, and the same way all the precipitation cannot be a double displacement reaction. A precipitation reaction is simply any type of reaction in which a precipitate or a solid is formed. A precipitation reaction can be a combination reaction, it can be a displacement reaction, it can be a double displacement reaction. Okay, if precipitate is formed, then that reaction can also be called as a precipitation reaction. And what is a precipitate? A precipitate is a solid thing which is formed as a product at the end of the reaction. The color of the precipitate depends upon the type of the compound which is formed. Like here, the type of the compound which is formed is the barium sulfate, BaSO4, which is a white color precipitate. Okay, so now let us see the definition of it. The precipitation reaction, reaction in which two aqueous solutions of two compounds on mixing react to form an insoluble compound which separates out as a solid, and this solid is called as precipitate. Okay, sometimes our precipitation reactions are also formed when we pass a gas, okay, over a compound solution that is in the aqueous state. There also we see the precipitation reaction. Remember, any reaction, whether it is a combination, decomposition, displacement, double displacement, if a precipitate is formed, that can also be called as a precipitation reaction. Okay, now let us move towards the neutralization reaction. So what is a neutralization reaction? Now, as if you focus on the first few letters of it, it is giving the word neutral to us. Neutral means what? Something which is not having charge, or something which is not able to react, right? That is called as the neutral thing. Like for example, the positive, like if you mix two equal charges, positive and the negative, result will be null, that is zero or neutral, right? In the same way, in the chemistry, when we study compounds, there are two types of compounds which are quite alike from each, like they are very much different from each other. One is acid, and the opposite of the acid is a base. Okay, now if an acid reacts with a base, it is called as neutralization reaction. Why? Because they cancel each other's effect. It is called as a neutralization reaction because it cancels each other's effect. Like positive cancels the negative effect, or the south pole or the north pole effect. Okay, so in the same manner here, we see that when acid reacts with a base, it is called as a neutralization reaction, and the product of the neutralization reaction is always salt and water. Always. There are various examples which you can form yourself also. Some of them I am writing here. I am taking a base NaOH. NaOH is a base. OH ones are the base, remember. KOH, then we are having NH4OH, ammonium hydroxide. Okay, they all are base. They all are base here. Okay, now acid, you can take HCl, or you can take H2SO4, let us say, or it is your choice. HCl again you can take here. Let us say you are taking HCl. This is an acid, HCl. This is again acid here. This is also acid, right? Now what will happen in each case? Na will combine with Cl here, leaving behind OH and H. So OH and H will form water, and Na will combine with Cl to form NaCl. Here again similarly you can show K will combine with Cl, it will form KCl, and water will come out, H2O. Here also NH4OH will combine with Cl and OH will be out. OH will combine with H to form H2O, and we will get NH4Cl. NH4 valency is 1, remember. Cl valency is 1. Many times I have told you how we form the compound. NH4 valency is 1, Cl valency is 1. This one will go to NH4, this one will go to Cl, and we will get the compound NH4Cl. There are more reactions I will show you. Wait. Now, how to define a neutralization reaction? It is very easy to define it. You just simply write that when an acid reacts with a base, we always get salt and water, and this is called as a neutralization reaction. With H2SO4 also you can write like NaOH is a base, it reacts with H2SO4. Okay, here also same thing, Na will combine with SO4 and OH will combine with H. So what will be formed here? NaSO4, and the compound will be Na2SO4 plus H2O. Why I have written here Na2SO4? See, Na is combining here in the reactant side, Na is combining with SO4. So this is SO4. Na valency is 1, but SO4 valency is 2. So this 2 will go to Na, this 1 will go to SO4. So the compound will be Na2SO4. Right. Similarly, you can make neutralization reaction using organic acid like acetic acid, CH3COOH. This is acetic acid. Okay, it is weak acid, you can say. So this is an acid, you can combine it with a base like NaOH. So what will happen here? That this Na will combine with COO. Okay, this is minus and this is H is plus, remember. Okay, so Na will combine with CH3COO, so it will form CH3COONA plus H2O will come out as water. So this is an example, all these are the examples of the neutralization reaction, and it is a reaction where simply an acid reacts with a base and the products are always salt and water. Okay, now let us move towards the next topic, which is the reduction oxidation reactions, or in short they are also called as the redox reactions. Now what are oxidation reduction reactions? Now see, oxidation means adding of O2. Adding of O2. Okay, opposite is reduction. Reduction is actually adding of H2 and removal of O2. Okay, similarly here also you can write it is adding of O2 and removal of H2. Okay, so they both are opposite to each other, and how we can identify that whether there is an oxidation which has happened in a reaction or a reduction, how we can identify it. Now before undergoing that, we will first try to understand a very simple experiment here. In a petri dish you can take copper. Copper is what? Copper is a reddish brown substance. You can take copper powder. Okay, in the powder form you are taking it here, and burn it. Okay, keep this petri dish over to some wire mesh, and from the bottom you can burn the lighter or the burner can be kept. And what will happen, that this copper will start getting heated up, and later on it will react with the oxygen component and it will form a compound copper oxide, and it is black in color. A black color substance will be there inside the petri dish. Now if you see in this reaction, what has happened, you have combined oxygen with the copper. Okay, you have taken the powdered copper in the petri dish and you have burnt this copper. Okay, while burning means what? That obviously whatever is there, it is combining with oxygen, and in the product you are getting the copper oxide. Here this is the copper oxide, right? So basically at the end of the reaction, copper has accepted oxygen, or there is a gain of oxygen in the copper. Right, now there is a gain of oxygen by copper, right? Why? Because in the reactant you can see that copper is alone. Okay, but in the product we are having CuO, that is a copper oxide or a compound having oxygen is formed. Okay, now if this copper oxide, if over to this copper oxide you pass hydrogen gas, if you pass hydrogen gas, what will happen? Then we will be seeing that after some time you will again get back the reddish brown substance. This reddish brown substance will be there again and water will be formed. Right, now what is happening here in if you change, or if you try to observe the change from the reactant to the product side, you are seeing that copper oxide, which was having CuO formula, is changing to copper. Okay, that is, there is a removal of oxygen. So there is a removal of oxygen. Correct. Now coming back to the topic oxidation and reduction. What is oxidation? Oxidation is simply the gaining of oxygen. Okay, so now here you can say in the first step, and this is the second step of the reaction. In the first step, copper has gained oxygen, right? Copper is changing to CuO. So this is an oxidation reaction. This is an oxidation reaction. And if you see here in the reaction 2, copper oxide is changing to copper. That is, it is losing the oxygen. So what is a reduction reaction? If you focus here in the definition side, what is happening? Reduction is removal of oxygen. So this is a reduction reaction. Right, so it is very easy to identify if you will focus on these keywords. If there is an addition of oxygen, then this is oxidation reaction. If there is a removal of oxygen, then that is a reduction reaction. In the same way, you can also say that if there is a removal of hydrogen, that is also called as an oxidation reaction, and if there is adding of hydrogen, and that is called as reduction reaction. Okay, now here we can try to understand one more point. For example, what are oxidizing agents and what are reducing agents? Now see, anything which is getting oxidized, okay, or which is getting reduced, they will act as the agents. Okay, for example, here this is the Cu and this is O2, right? They are combining and they are forming CuO, that is the copper oxide. So there is a gain, of oxygen, right? Now here CuO is getting reduced to Cu. Okay, now here it is losing the oxygen, and that is why this is a reduction reaction. So who is giving oxygen here? Here copper is giving oxygen. So it will be called as the oxidizing agent. It will be called as oxidizing agent. Now if it will not have oxygen, then how it will form Cu plus H2, right? So who is giving oxygen? That will become as the agent there. So CuO is called as the oxidizing agent here. Or a very smart way is that whosoever is getting oxidized or reduced, they will become opposite agents. Like for example, CuO is undergoing the reduction reaction. So CuO will be called as oxidizing agent. Agent means what? Someone who can give you something now. So here this agent is giving, or it is having the oxygen, which will later on will not be there in the product. Okay, so that will become as an agent. So here it is oxidizing agent. Okay, it will become more clear with more example, which we will be seeing later on. So what are oxidation reduction reactions? Okay, oxidation is defined as a process which involves gain of oxygen or loss of hydrogen. Reduction is a process which involves gain of hydrogen and loss of oxygen. What are oxidizing agent? Any compound or any basically compound here which can give oxygen or it gains hydrogen, that will become as oxidizing agent. And what are reducing agent? Which gives hydrogen and gains hydrogen. Okay, here which gives hydrogen, and here it will be which gains oxygen. Actually it should be like that. Now we can also say the same thing whatever I'm telling you, that if you are seeing that this compound is undergoing the oxidation reaction, that will be a reducing agent, which will be a reducing agent. And if you are seeing that a compound is undergoing the reduction reaction, then that particular compound will become the oxidizing agent. Okay, because see, they are alike. They are alike. That is gain of hydrogen, loss of oxygen. So here also gives means loss here, and gain of hydrogen. And oxidation is alike to the reducing agent. Okay, there is a gain of oxygen and there is a loss of hydrogen. You can take another example, like for example, if we will take the or we can go with the reaction, there also you will be able to understand like this. Okay, so here I have kept few reactions. I'll try to explain them one by one. Now see, ZnO plus C gives you Zn plus CO. Okay, now if you see ZnO, ZnO is changing to Zn, right, in the product. Now ZnO is losing its oxygen. It is losing its oxygen. So loss of oxygen is called as reduction. So this is what? This is a reduction reaction, right? Now ZnO is undergoing a reduction reaction. So ZnO is the agent, okay, which is losing its O. So it will become the oxidizing agent. It will become oxidizing agent, and Zn is the reduced one. Similarly, if you see C, here C is changing to CO. So there is a gain of oxygen. The C is accepting the oxygen. So this is an oxidation reaction. There is a gain of oxygen. So this is an oxidation reaction, right? And C will become the reducing agent. Okay, if you are able to identify correctly the oxidation and the reduction reaction, then that particular compound will become opposite of that particular reaction. Like for example, ZnO is undergoing the reduction reaction. So ZnO will be called as the oxidizing agent, because it is the agent which is ultimately giving the oxygen here. Okay, now if you go to Cu plus AgNO3, here Cu is changing or it is gaining O in the product, that is Cu is changing to CuNO3 whole twice. So there is a gain of oxygen by Cu. So gain of oxygen means it is an oxidation reaction, right? If it is an oxidation reaction, then it will become reducing agent. Similarly, if you see AgNO3, AgNO3 is changing to Ag, that is Ag is losing its O, so it will become a reduction reaction. It is a reduction reaction, and AgNO3 is what? It is an oxidizing agent. Okay, I will be marking OA as oxidizing agent, remember here. And reducing agent will be Ra. Okay, so always remember, if that particular compound is undergoing the oxidation reaction, then mark it as the reducing agent. Okay, and if a particular compound is undergoing the reduction reaction, mark it as oxidizing agent. Now MnO2, if you see MnO2, it is changing to Mn in the product. So Mn is losing its O ultimately. So if there is a loss of oxygen, then that is a reduction reaction. Okay, and Mn is what now? It is an oxidizing agent. Al is gaining O. Al is changing to Al2O3. So it is gaining oxygen. So it is the oxidation reaction here. And Al is acting as the reducing agent. Now coming to Fe2O3 plus CO, Fe2O3 is changing in this to Fe, that is there is a loss of oxygen. So it is a reduction reaction. Okay, and Fe2O3, it is acting as the oxidizing agent. CO is gaining O because CO is changing to CO2. So this is oxidation reaction if there is a gain of oxygen, and CO will change to, or it is also called as reducing agent. Right, let us see more examples to make the concept more clear. Fe2O3 plus Al gives us Al2O3 plus Fe. Now see, Fe2O3 is changing to Fe, that is there is a loss of oxygen here. Okay, so this is a reduction reaction. So it is an oxidizing agent. Al is changing to Al2O3. There is a gain of oxygen. So this is oxidation reaction. And it will be becoming the reducing agent then. H2S plus SO2. Here H2S is changing to H2O. That is there is a gain of oxygen by hydrogen. H2S is changing to H2O, that is there is a gain of oxygen by the hydrogen here. Okay, so this is what, this is oxidation reaction. And SO2 is changing to S, that is there is a loss of oxygen by SO2. So loss of oxygen means it is a reduction reaction. So SO2 will become oxidizing agent, H2S will become reducing agent. Now if you see this one, MnO2 is changing to MnCl2, manganese. Mn is what? Manganese. It is not magnesium. So MnO2 is changing to MnCl2. So O is not there in the product. So it means what? There is a loss of oxygen. If there is a loss of oxygen, this is a reduction reaction. And MnO2 will become oxidizing agent. If you see HCl is changing, or it is having O in the product. It is changing to H2O2. There is a gain of oxygen. So it will be oxidation reaction. And HCl will act as reducing agent. PBS is changing to PbSO4 here. So PBS is basically gaining the oxygen in it. So it will become oxidation reaction here. And H2O2 is changing to H2O. That is there is a loss of O ultimately. So it is a reduction reaction. So PBS will change to, or it will act as the reducing agent, and H2O2 will act as the oxidizing agent. Okay, so with these examples, I think it has become clear to you that whenever there is oxidation, at the same point of time there is a reduction reaction also which is occurring, right? So basically in a chemical reaction, both reduction and oxygen goes simultaneously. Okay, reduction and oxidation, they occur simultaneously. In all these examples, you have seen that if one is getting under reduction reaction, another one is going under the oxidation reaction. If someone is losing O, there is someone which is accepting O, right? So they both go hand in hand in a chemical reaction. Reduction reaction cannot occur alone. Similarly, oxidation reaction cannot occur alone. They both go hand in hand. They occur simultaneously in a chemical reaction, and that is why reduction and oxidation reactions are also called as redox reaction. Re from the reduction and Red from the reduction, OX from the oxidation. So they are together called as redox reactions. Okay, redox reaction can be a combination reaction, it can be a decomposition, it can be a displacement, it can be a double displacement, any type of reaction. In all the reactions, basically we see that there is reduction and oxidation which are occurring together or simultaneously they are occurring. So in the class 10th, this is a simple concept of explaining the oxidation and reduction reaction, but there is a higher, better concept to understand the oxidation and reduction reaction using the gain and loss of electrons. Okay, but that is not the part of class 10th NCERT book. Okay, you will be able to understand it in the class 11th. So in the class 10th exam, use the concept of gain or loss of oxygen or the hydrogen as reduction and the oxidation reactions. Okay, remember the compound which is undergoing the oxidation will act as the reducing agent. The compound which is undergoing in a reduction reaction will act as the oxidizing agent. Okay, so it is very simple, and I have given you or shown you a lot of examples about the oxidation and reduction reaction. In my next session, I will be finishing up this chapter, and then we will be doing a Q&A from this chapter also. Okay, so till then, bye bye.